Okay, so we are doing lesson 1.2 now, where we're going to solve multi-step linear equations. The last lesson we solved equations that only required one step. Whether it was, and the one step that we did was doing an inverse operation, right? We looked at whatever operation was happening to the variable, and then we did the inverse operation in order to get the variable by itself. Now we're going to look at problems that take more than one step to solve. And the general rule is that you're going to simplify, simplify each side of the equation first, if necessary. Sometimes it won't be necessary, but you'll simplify using like combining like terms or using the distributive property. And then after you have simplified each side, if possible, then you're going to use inverse operations to isolate the variable. Now, what ends up working out is something we're going to go over in the next page, is the order that, you know how like you've heard of something called order of operations before? Like you have to do the exponents and first, and then stuff inside parentheses, and then multiply and divide, and then add or subtract from left to right on the last two. Well, that's when you are performing the operations, right? But when you're doing inverse operations, we do the inverse of them when we're solving. We actually do those kind of in reverse PEMDAS order, right? When we're simplifying expressions, that means that we're doing the operations. We do PEMDAS. We use that order of operations because we are doing the operations, right? We're performing them. When we solve equations, we're doing inverse operations. We're undoing the operations. So we undo them in the reverse order. So like SADMET. But how that will present itself to you most often is what I have down here in purple. When we're solving equations, we undo addition and subtraction before we undo multiplication or division. And this is like 99% of the time. There's certain situations where you can do it differently. Sometimes equations are set up to where you can do other things where it might be a little easier. But in general, when you're solving an equation, you want to get rid of addition happening to your variable before you get rid of multiplication or division. Okay, so here's an example. We're going to solve the equation 2.5x minus 13 equals 2, and then we're going to check our solution. Okay, so we're going to look at both sides first, because remember the first step was simplify on both sides if you can. So simplify means to do operations, right? If there's like terms to combine, we can combine those. If there's parentheses that we can use the distributive property with, we do that. Looking at this problem, we don't see any of that stuff. On the left side, we just got 2.5x minus 13. We've only got two different terms here. One of them has an x, one of them doesn't, right? So we can't combine them. On the right side of the equation, it's just the number 2. There's nothing to do there either. So both sides are already simplified. So now we just go into doing the inverse operations. So just as a visual way to kind of remind you that we're focused on the variable, I'm going to highlight it. And we're focused on what operations are happening to the variable. And then we're going to undo those operations, right? And since we're undoing them, we want to undo them in reverse PEMDAS, right? So what is happening to the variable? We've got multiplication by 2.5, and we've got subtraction by 13. So which one do we undo first? The subtraction, right? And so the inverse of subtraction is addition. And we want to get the minus 13 away from our variable. So we're going to do the opposite of minus 13. We're going to do plus 13 once on each side of the equal sign. So the minus 13 and plus 13 are inverses. So they, in a sense, cancel each other out. What really happens is minus 13 plus 13, that makes 0. And you're doing 2.5x plus 0, which is just 2.5x. And then 2 plus 13 is 15. So now, once again, we're going to focus on our variable. What's happening to our variable? What operation is going on with our variable? It's being multiplied by 2.5. So the inverse of multiplication is division. So we're going to divide both sides of the equation by 2.5. Because the 2.5 divided by 2.5 is 1. So they, in a sense, cancel out because that's just 1x left over here. And then we can use a calculator for this part. 15 divided by 2.5 should be 6, I think. Yeah. So x equals, whoops, come back to me. X equals 6. And then you can check the solution, right? 2.5 times 6 minus 13. Does this work out? 2.5 times 6, if you multiply that. That's not what I was trying to click. 2.5 times 6 is 15. So 15 minus 13 equal 2. Yes. So we're happy. So a question for you, like we're done with this one, okay? We found the solution. We checked our solution, so we're good, right? I just want to throw a little thought on you to why we want to undo the addition and subtraction before we try to undo multiplication or division. Imagine if we had tried to undo the multiplication first. Let's say we got 2.5x minus 13 equals 2. Technically, you can do that, right? It's just going to end up being harder. So you don't have to write this part down. I just want to show you why we will undo addition and subtraction before we undo multiplication or division. If we tried to undo the multiplication right now, remember, you have to multiply both sides of the equation by the number or divide both sides of the equation by the same number. So that means that we would have, if we were going to try to get rid of the multiplying by 2.5 right now, we would have to divide this whole side by 2.5 and then this whole side by 2.5. And it could still work, right? We would have to divide these kind of individually. 2.5x divided by 2.5x, that's just x. Minus, then you got to do 13 divided by 2.5. See how there's extra stuff to remember? So 13 divided by 2.5. Let's see how much harder it makes it when we do it backwards. So 13 divided by 2.5. Nope, 2.5. And you didn't get the 3 either. 13 divided by 2.5. So that's 5.2. And then 2 divided by 2.5. See how this is more work? Because what really happens is you end up getting fractions over here a lot, or you get all these wacky decimals, right? So 0.8. And then we could get rid of the addition or the subtraction using addition, adding 5.2 to both sides. And you'll get x equals 6. Same answer, same solution, just a different method, and it was a little bit wonkier, right? And if this wasn't a decimal, you probably would have just been seeing fractions over here. And sometimes if you try to do that, you'll get something that doesn't come out to a terminating decimal. You'll get like a repeating decimal. And then if you use that decimal, especially if you're like a lot of times you'll use like you'll enter an answer in and the computer will tell you if it's wrong or right. If you do it the decimal way and it gets like a non-terminating decimal, you're going to end up rounding to put your answer in, and then it'll count it wrong because it's not exact. So by by undoing addition and subtraction first, we simplified the solving process a lot. Here's a fun one. So this one is going to involve some combining like terms before we get to inverse operations. So we've got negative 12 equals 9x minus 6x plus 15. So with multi-step equations, one thing I talked about in the last lesson was sometimes people will make this mistake. It's tempting to do something like this, like, oh, minus 6x, I need to do plus 6x. And then you'll be like, okay, plus 6x here. What's wrong? What's wrong with doing this?
Is that multiplication on the line?
No, actually, what's happening right here is if we do this right now, where we're adding 6x twice on the same side of the equal sign. So we just threw our entire equation out of balance. We added, what we did right here was we added 12x to the right side and we added nothing to the left side. So when you have things that are on the like terms that are on the same side of the equation, you just combine the like terms, right? One thing I like to say, if you have like terms with operations and they're on one side of the variable, you just do what it says, right? What's 9x minus 6x? 3x, right? So if they're on the same side, you just do what it says. If they're on opposite sides of the equal sign, that's when you have to do the inverse operations. But if you have like terms, so right here we have, I'm going to write this down here. Like terms on the same side of the equal sign. If you have like terms on the same side of the equal sign, you just do what it says. Combine them. Right? So what did it say here? It said 9x minus 6x, and we got 3x. So on this step, all we did was we just combined like terms on the right side of the equation. Now that we have simplified as much as we can on both sides of the equal sign, because there's no more like terms on the right side, there's nothing going on the left. Now we can start doing inverse operations to isolate the variable. So our variables right here, the operations that are happening around our variable is multiplication by 3 and adding 15. We want to undo the addition before we undo the multiplication. So I'm going to subtract 15 from both sides. Make sure you're always doing it once on the left of the equal sign, once on the right of the equal sign. So these undo each other, so we just are left with 3x on the right side. Negative 12 minus 15 is negative 27. And now if you look at our variable, the only thing that's happening to x now is it's being multiplied by 3. So we're going to do the inverse of multiplying by 3, which is to divide by 3. So we divide each side of the equation by 3. And we get x equals negative 9. Okay, I'm on the video, I'm not gonna like go over these. I'll just show you the answers, and so that like you can kind of take your time to pause or take your time to do them. Like that's what I wanted to record this ahead of time so that you could just pause right here and work on them. So I guess we could take a little time to let you work on these. It's just going to be a big lag in the video. So get ready for a quiet spot in the video. I'll give you guys a few minutes to try those. Okay, folks, if you're not done with these, just leave a little space in your notes so that you can finish them up later. I'm going to go ahead and show the answers and let you write those down too, so you have time to like check and make sure that you're doing them right. And if you got something different, then we can go over like try to find out where a mistake happened. Okay. Everybody got that the answers jotted down? Okay, so this one, I want to show you two different ways. Like when you get into solving equations, the further you get into it, the more you realize there's going to be a bunch of different ways that you can go about solving the equation. But as long as you're doing something that follows the rules of algebra, you're okay. So we're going to go over two different ways to solve this one. So if we follow the method that we've been talking about, which is simplify each side first if possible, and then do inverse operations. In order to simplify on the left side here, we can use the distributive property, multiply the 2 by both terms inside the parentheses here. So we're distributing the 2. 2 times 1 is 2. 2 times negative x would be minus 2x. And then we just write the rest. Plus 3 equals negative 8. Then we've got like terms over here on the left side, a 2 and a 3. Right, so this positive 2 and this positive 3 are like terms, so we can just combine them. We're just going to do 2 plus 3 is 5. So that we get 5 minus 2x equals negative 8. I also could have written it negative 2x plus 5. Those would mean the same thing. Writing it like this kind of might look a little bit confusing because you're like, how I'm used to saying something x plus or minus some other number, right? And this one looks kind of backwards. But what we're still going to do is, no matter what our equation looks like, we're going to focus on the variable, identify what operations are happening, and then undo them in reverse PEMDAS, right? So right here we have, so our x is like multiplied by negative 2. And then there's this 5 over here. What's the 5 doing? Is it adding, subtracting, multiplying, dividing? Even though there's not a plus sign in front of it, it's actually being added, right? Because we got 2 plus 3 is positive 5, right? Which means it's 5 more than negative 2x. So this is actually, we treat this as addition, because we could write this as negative 2x plus 5, and that would mean the same thing. So what we're going to do is we're going to get rid of that positive 5 first. It's a positive 5, so we're going to subtract 5 from both sides of the equal sign. So on the left side, if you think about what's happening, 5 minus 5 is 0. 0 minus 2x is just negative 2x. Negative 5 minus 8 is negative 13. And then our x now, the only operation happening to x now, it's multiplied by negative 2. So we're going to divide by negative 2. So we divide both sides by negative 2. Negative 2 divided by negative 2 is positive 1. So 1x is what we're left with. And if you just have 1x, you don't have to write the 1, because you can tell you just have 1x there. So negative divided by negative is positive. 13 divided by 2 is 6.5. Okay, so that was solving it by simplifying first, using the distributive property and combining like terms, and then using inverse operations to isolate the variable. Now I want to show you a second way to do it. The second way, I want to treat, instead of just looking at the x if I look at this whole chunk right here and treat this as a thing to solve for first, then what I can do, so if I just imagine that whole highlighted thing is like kind of like just my variable that I'm going to solve for, I would think about what are the operations happening to that chunk, right? It's being multiplied by 2 and then adding 3. So if I wanted to get this yellow part by itself, I could subtract 3 from both sides. Then after that, divide both sides by 2, right? So I'm gonna do that. So I'm going to do -3 once from each side of the equal sign. So then we get 2 times 1 minus x equals -11. Then once again, I'm gonna think about this whole chunk as how can I get that chunk by itself? It's being multiplied by 2 right now, so I can divide both sides by 2. Two divided by 2 is 1, so these cancel out. And then we're just left with 1 minus x equals the -11 divided by 2 would be -5.5. Now look at x. We've got a 1 with it, right? It's a positive 1. So in order to get rid of a positive 1 that's not multiplied by the x, we would have to subtract 1. So I'm going to subtract 1 from each side of the equal sign. And then I have -x equals -5.5 minus 1 is -6.5. So over here I got x equals 6.5. Over here I got -x equals -6.5. They're the same because -x, you can think of that as x being multiplied by -1. So you can just divide both sides by -1. And all that is going to do is change the sign. So it's x equals 6.5. So as you can see, you have options sometimes, but as long as you're not breaking any rules, then you're going to get the right answer. Do that another time. And then let's go over this one. So here's a real life problem, word problem time. Use the table to find the number of miles x you need to bike on Friday so that the mean number of miles biked per day is 5. So mean is like the arithmetic average, which means you add them all up and divide by how many there are. So, and we want the mean to be 5, right? So how do you find the mean? We want the mean equals 5, right? Well, how do you find the mean? You add them all up and then divide by how many there are, right? So the mean would be 3.5 plus 5.5 plus 0 plus 5 plus x divided by 5. 1 second. Isabella, Laura? Okay, so the mean, you find the mean by adding up all 5 values and then dividing by 5. And then we want the mean to be 5, right? So now we've got an equation that looks sort of crazy, but if you look at what's happening to the variable, we can simplify, we can follow our steps, right? We can simplify both sides. The right side doesn't really need any simplifying because it's just the number 5. But on the left side, we can add together all these numbers, right? So 3.5 plus 5.5 would be 9. 9 plus 5 is 14. So this is really 14 plus x, or x plus 14. So right there, I just combined like terms of all the numbers in the numerator here. Added those all together to get 14. Okay, now what do I do? Now, normally I said like we want to get rid of addition and subtraction first, right? But this plus 14 is locked up in the numerator, right? That's kind of like being in a grouping symbol. So we can't undo that yet. We have to undo the dividing by 5 first. So because this really isn't just plus 14, it's really plus 14 divided by 5, right? It's x divided by 5 plus 14 divided by 5. So what we need to do right now is we can get rid of the divided by 5 on the left side by just multiplying both sides of the equation by 5. So I'm using the multiplication property of equality. I'm just multiplying both sides of the equation by 5. So on the left side, the times 5 and divided by 5 will cancel out, and we'll just be left with x plus 14. And then on the right side, 5 times 5 is 25. And then tell that we just need to subtract 14 from both sides of the equal sign. And we get x equals 11. So that means, so now one thing to remember is if you get a question that looks like this that says solve, and your answer should just be like x equals a number, right? You're just solving an equation. You're finding out the solution. What does x equal? On this question, they're actually asking you a question in words, so you need to give an answer in words. Use the table to find the number of miles x that you need to bike on Friday. So your answer should be, I need to bike 11 miles on Friday. Right, and then you could check, right? Add up 3.5 plus 5.5 plus 5 plus 11, divide by 5, and see if you got the right mean. So 3.5 plus 5.5 plus 5 plus 11 is 25. Divide by 5 because there was 5 days, and your average is 5 miles a day.